I'm going to try this again. I was on the word mode and my computer crashed. Surprise, surprise. So we switched to Smartboard, so we'll see how this goes. But now, one thing I noticed in this example is the like if I start to think about, okay, I'm trying to measure things and bound things, for my curve, like trying to identify what's top and what's bottom. What's top and what's bottom. Because if I want to find the area of this region, I need to sort of know what's my top boundary and what's my bottom boundary. But here's the thing. As I start measuring this down to over here, once I get past like -1, all of a sudden between like, I don't know, like this part from -1 back to like -3, the parabola is itself. It's its own boundary. Like if I do the top part minus the bottom part, I'm subtracting itself. In other words, I'm going to get 0. And I know there's some, I can physically see there's area. So I know it can't be 0. So there's occasionally times when your boundary is the same function, like the sideways parabola sort of prevents me from doing a top and a bottom function. Now, if it stopped here, it'd been great because, this region right there, all of that has 2 separate boundaries. But for us, it's a bit of a problem. So we need to come up with another way to represent that area. And then as long as I can bound it by 2 separate equations, that's all I need. And so now if I think, okay, if that's all I need, and, and so I, instead of thinking about measuring things, top minus bottom, there we go. What if I start measuring right minus left? In this direction. Like if I think, okay, on the right side, it's linear. On the left side, it's the parabola. On the right side, it's linear. On the left side, it's a parabola. On the right side, it's linear. On the left side, it's a parabola. And in fact, no matter where I measure, no matter where I measure, like this right side minus left side, right side minus left side is always going to be bound between the linear function and the parabola. And so that's my key here. I want to bound things right to left. And I've said that a couple times. I'm even going to write this down because I think that's so important, especially as you start learning this. Like when you are in that, like when you have to bound things in the opposite direction, like a horizontal direction, you want to measure things right to left. And that might be counterintuitive at first, but think about what you're doing, right minus left. You're taking the larger value, which is towards the right, like the more positive x, that's the larger value, minus the smaller value, which is on the left. So when I measure this, I want to do the right minus the left. And I want to be in terms of y. That's the other key. Like before, I kind of think about this. Before, when I was measuring in this direction, I would do top minus bottom. And so I'm just trying to mimic kind of like, well, top minus bottom, the bigger one came from the top, the smaller one came from the bottom, and we were in terms of x. And that's kind of like that vertical distance, the vertical line. Here, when I'm in terms of y, it's going to be right minus left to still go bigger minus smaller. So that's a good key that when you are having to measure your area between 2 curves and you have to go from the right side to the left to go in a horizontal direction, make sure you are bounding right to left, right to left, right to left, and make sure that you are in terms of y. Okay, now I can see that the right side is linear. In hindsight, I can also see that the equation they gave us already was solved x in terms of y. And that's a little bit strange until you realize, oh yeah, I need that. So when I set up my integral, like I know the right side is going to be y plus 1. And then the curve here, the left boundary, is going to be, again, already solved for y. 1/2 y squared minus 3. Now, the things that I have not added yet are the boundaries. I need to figure out what's the lowest bound and what's the highest bound. And what we have to remember and be careful of is that this lower point, this boundary here, and this boundary here, actually, they have 2 coordinates. There's an x and a y component to it. And I've got to realize that if I'm in terms of y, this point, which is -1, -2, if I'm in terms of y, then the part that's really important is this -2, because that's the y value at that instant. And up here, this has a coordinate of 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's 5, 4. But what's most important is that it has its y component is 4. And so again, thinking about these, like, oh, maybe I'll pick up this nice screen again. Thinking about, like, measuring this, the right minus the left, the right minus the left. If you stack them up like pancakes, it's kind of breakfast time. If you stack them up like pancakes, where does the lower one start? Oh, it starts at -2. Where does the top one end? Oh, it ends at 4. So you're measuring right to left, starting at -2 and ending at 4. Starting at -2 and ending at 4. So make sure you do have the bounds in terms of y, not in terms of x. Okay, once you do that, like once you set up your problem, it does not matter what letter your integral's in. You just still treat it normally. So I'm going to maybe try to maybe simplify some things here. So I know I've got a y minus. Oh, actually, I'm sorry, a 1 minus a -3, so I could combine that. So I have a y, 1 minus -3 is +4, and then I have a -1/2 y squared in terms of y, and I'm integrating from -2 to 4. So then if I do my antiderivative, again, doesn't really matter because I'm in terms of y. So y squared over 2 plus 4y minus 1/2 y cubed over 3 when evaluated from -2 to 4. So that's going to represent the area under the curve. Or I shouldn't say under the curve. I should say that's the area between these two curves. And notice I'm using the word curve because in this direction, they're not functions. We're x in terms of y, but that's okay. We're just measuring that area or amount of space that it takes up. So when I put in 4, so I get 4 squared is 16 over 2, plus 4 times 4 is 16, minus 4 cubed is 64. So I have 1/2 times 64 thirds minus, and again, I like to use parentheses. So -2 squared is a +4, plus 4 times -2, which is -8. -2 cubed is another -8 over 3. And so again, just be careful of your negatives. So 16 over 2 is 8. 8 plus 16 is 24. 2 goes into 64 32 times, so it's -32 thirds. So I can simplify that in a second. And then 4 over 2 is 2. And then I have 2 minus 8, which is -6. And then this becomes a negative, so positive 4 thirds. Like that, because 2 goes into 8 4 times, and there was 2 negatives. So if I think about this, 24 minus 32 thirds minus a -6 plus 4 thirds. Let's see, 24 plus 6 is 30. -32 thirds minus 4 thirds is -36 thirds, which is 18. So it looks like I have 30 minus 18, which is an area of 12. And obviously simplify that as needed. If that makes sense, how you simplify, you could, however you get that value of 12 at this point, if you jump to your calculator, that's fine. Hopefully I didn't make any arithmetic mistakes. If I did, shoot me an email. Okay. So, but I want to stress again the importance of everything in this example was in terms of y. Okay. Now, in this example, I notice, okay, things x in terms of y, x in terms of y, but they don't give me a picture. So I'm anticipating this is going to be in terms of y. I'm anticipating right minus left, but I don't have exactly where, what is the lower bound, what is the upper bound. So I'm going to have to actually do a little bit of algebra first. Okay, so I want to know, when does -2y plus 6, when does that equal y squared minus 4y minus 2. So set it equal to 0. Add the 2y over, so it's minus 2y. Subtract the 6 is minus 8. Hopefully it factors. If not, we can always complete the square, or worst case scenario, quadratic formula. But here we go, y minus 4, oops, y plus 2, not x, y minus 4, y plus 2. So I get two values, y equals negative 2 and y equals 4. So at least I know my boundaries. Lowest boundary is negative 2, upper boundary is 4. What I don't necessarily know is which one's to the right and which one is to the left. And so I might have to sketch this out a bit. And when I sketch this out, one thing I know about y squared, if it's a positive y squared, it's opening to the right side. But the question is if I'm opening it to the right, does that guarantee that the linear function would be on the left? So I just want to make sure I can kind of get a sketch here, just to know and confirm which function's on the right and which function's on the left. And a good way to do this, I know, for example, that when y is negative 2 and y is 4, I know that that's the starting point, ending point where there's going to be an in-between. So if you pick any y value that's in between these two, and you can then put it into these functions to see, okay, which one has the greater x value? The greater x value would be the one that's more to the right. So, again, if I think about, drawing this xy axis here, and I say, okay, if you're doing negative 2 and 4, let's pick y is equal to 0. That's an easy one. So y equals 0. So if I put 0 into this function, negative 2 times 0 is 0, and 0 plus 6 is 6. So 0, 6. So when y is 0, the x value of this function is 6. And when I put y is 0 here, x is equal to negative 2. So now, because this function has a greater x value than this function when y is negative 2, this is the right side and this is the left side. So that I know when I sketch this graph, here's your linear function, and then here's your quadratic function. And really that's it. It just has to be a sketch. I already know the lower bound is negative 2 for a y value. I already know that the upper bound is 4 for the y value, and I'm measuring right to left, right to left, right to left, right to left. And if you're a little bit uncertain or anxious about drawing these out, the trend on the AP exam has been that they usually do give you a picture. They usually do. They don't have to. So you should be prepared to know, how do I do that? How do I actually measure this right to left? And then actually get a quick image of it if I don't have a graphing calculator. So once we're at this point here, we set up our integral. We already knew it was from negative 2 to 4. The right side is linear, so negative 2y plus 6 minus the left side, y squared minus 4y minus 2. Now, it might be a good exercise for you to just pause the video and actually solve the problem, and then then hit play and see that did we come up with the same answers. If you still want to watch me and go through it, that's fine too. So I might do some simplifying. So I see a negative y squared to start with. Negative 2 to 4. I have negative 2y minus a negative 4y, so it's actually plus 2y. 6 minus a negative 2 is plus 8. Now, if you're like me and you start to notice patterns, one thing you may have already noticed is that when you look at this integral, it's all of the signs actually are exactly opposite of when we solved for our particular quadratic. So I don't know, it's kind of interesting. I noticed that. So something to kind of keep track of, that kind of gives you maybe an indication that you're on the right track. So antiderivative, we have negative y cubed over 3 plus y squared plus 8y when evaluated from negative 2 to 4. Okay, so 4 cubed is 64, so we get negative 64 thirds plus 16, which is 4 squared, plus 32, which is 8 times 4, minus, and again, using parentheses, just so I don't make a sign error, negative 2 cubed is negative 8, so I have a negative 8 thirds, because that negative is outside, plus negative 2 squared, which is a 4, and then minus a 16, because 8 times negative 2 is negative 16. So this is negative 64 thirds plus 48, as on the left, minus, I have a negative, so a positive 8 thirds. 4 minus 16 is negative 12. So I have 48 minus a negative 12, which is 60. And then I've got negative 64 thirds minus 8 more thirds. So that would be negative 72 thirds, which actually is 24. So 60 minus 24. So I believe that should be an area of 36. And let me just double check my math. Negative 64 thirds plus 48 minus 8 thirds plus 12. Should be an area of 36. Checked out. Okay, so we can look at the next example. And really, like that's kind of what this practice is just, different examples. Maybe sometimes you have to measure right to left, sometimes measure top to bottom. Sometimes you have a choice. And so as I look at example 15, just from the perspective of, should I go top minus bottom? Should I go right minus left? One thing I'm noticing is that if I go top minus bottom, I'm bound between two functions. But if I go right minus left, I'm also bound by two separate functions or two separate curves. So I have a choice. I think more naturally we think top minus bottom. We think in terms of x. So I think I will keep with that. But the other piece I notice is that there are two regions or two portions of this curve. One of them, like from 0 up to, 2 here, the top function is actually the linear one, and the bottom function is the quadratic. If I look from negative 2 to 0, the roles reverse. So now all of a sudden the top function is the quadratic, actually cubic, I should say, to correct myself, and the bottom actually is linear. So in that case, I need to be very careful. When I set my integral up, I need to make sure that when I'm going, good, excellent. My battery mode is plugged in for better performance, and it's fully charged. Thank you. So now I have to be careful. When I'm doing the green section, the top function is different than the blue section. So negative 2 to 0, from negative 2 to 0, the top function is f of x, which is the 1/3 x cubed plus 2. And the bottom function is the linear, which is 1/2 x plus 2. But then I need to add the blue function to that, or the blue region, I should say. So that goes from 0 to 2. The top function is the linear function, and the bottom function is the cubic function, but both in terms of x. Now, I also know that these are both odd functions, and this has been translated up 2 units. And so basically, they actually are the exact same areas. So I can use that odd property to say, well, what if I just find one of the areas? Maybe I just find this area and then just multiply by 2 once I get my answer. And that's exactly what I'm going to do. So I'm just going to evaluate this second integral here and then get an answer and multiply by 2. So again, maybe I'm going to do a little simplifying first. So I have an integral from 0 to 2. I only have just 1/2 x. 2 minus 2, that was nice, 0. And then minus 1/3 x cubed. And then I'll just have to remember, when I'm all said and done, don't forget to multiply times 2, because there are 2 regions. Okay, antiderivative, 1/2 x squared over 2 minus 1/3 x to the 4th, there it is, over 4 when evaluated from 0 to 2. And so let's see, 1/2, so that's 1/4, and then x squared, so 2 squared, minus 1/12 times 2 to the 4th power. Finally, another example of zeros. 0 minus 0. Okay, so then 2 squared is 4. 1/4 of 4 is 1. And then 2 to the 4th power is 16. And then 16, let's see, 16, 16 twelfths. Let's see. I feel like I maybe made a mistake here. Top function minus bottom function, 1/2 x plus 2 minus 1/3 x minus 2, 2 minus 2, 1/2 x, x to the 4th over 4, x squared over 2, 1/4, 2 squared is 4, 2 squared, oh no, that's right, 2 to the 4th power is 16 over 12 is 32, but for some reason I'm getting a negative number, and so for the life of me, I cannot figure out what I did wrong. Dun, 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 dun. What am I doing wrong? What am I doing wrong? Top function minus bottom function. Top function minus bottom function. 1/2 x plus 2 minus 1/8. Oh, that's why, because I can't read. It's 1/8. I can't read my own handwriting. 1/8. Okay, and you guys are probably at home thinking, Mr. Brown, what are you seeing? What are you doing? Crazy math. Okay, 1/8, 1/8. And so then that's actually 1 over 32. So let's try that again. Let's erase this part here. Because I want it to actually work out. So here we go. So that's 2 to the 4th is a 16th, but this is over 32. That's much better, minus 0. So you get 1 minus half, which is equal to half. Now, this area of half is the blue. Remember, we have to multiply by 2. So then we take that times 2, and we actually get an area of 1. Thankfully, I found my mistake because I knew it needed to be positive, right? I knew that when I'm bounding region, bounding area, I know it has to be positive. Fantastic. Okay, so we've got example 6 and then 2 more examples. So I'm gonna we'll take a look at those. I'm gonna stop this and set up another video just for lengthwise. So again, if you want to do a couple of the examples, try them on your own, and come back and check in the video. That's awesome, but you don't have to. And then we'll just go from there. Maybe.